Today we're going to be learning a cool word called Forpy, spelled F-O-R-P. Now what is Forpy? Well, Forpy is kind of like hex, but even simpler. Hex basically contains letters 0 to 9 in binary and A to F that represent bigger numbers, but also in binary. And binary represents a bit of colors for RNGB, or red, green, and blue. Now, searching it up, red, yellow, and blue actually are the prime colors that make all the other colors, so we're going to be using that. So we'll use R for red, we'll use yellow, and we'll use B for blue. Now here's how Forpy works. There's going to be a 4-digit number, and each digit has a value. Kind of like in math, there's a ones, there's a tens, there's hundreds, and there's a thousands. Let's go over each place value. The thousands are the biggest. They control which color. So, such as if 1 was in the thousands place, it would be the first color of the rainbow, which would be red. So if you saw 1 blank blank blank, you already know that 1 is going to mean we're going to have a color that's somewhat red. If it was 2, then it would be orange. If it was like 6, it would be purple. So it would be red, orange, yellow, green, blue, purple, and pink. And then there's 0 for gray, but I don't know how that would really work. So it just basically controls what color of the rainbow we're going to be using. So if the 5th color of the rainbow is blue, so if it's 5, it would be blue. Anyways, let's go back. The next letter, the hundreds, the next place value, the hundreds. The hundreds controls the vertical. And if you don't know how the vertical works, it's basically we're using this square, and this is recommended for using Forpy. And it's basically sliding it up. Do you see the cursor? It's sliding this up, and it makes it brighter. So the higher the number, the higher the brightness is of the color. So if it was 9, it would be set to max. If it was 0, it would just be black. And if it was 5, it would be somewhere in the middle. And if it was 8, it would be like around right there. So take 8 for instance, and we take our blue, and it would kind of look like this, mainly because we haven't gone into the next crucial place value that will let us actually see the color. So now the tens, which is the horizontal, it will let us see the color now. So we want the horizontal to be high to recognize the color. So if you go 9 and a 9, you can see the vertical controls the brightness, and the horizontal controls the saturation of the color, which you can recognize the color. But we need an actual placeholder for the color itself. You just don't see the color until we use the horizontal. The horizontal also has to be very high. So the higher, the more saturated, or the more the color looks like itself. Then we have the ones, which also actually play a big crucial role. So you see that red, orange, yellow, and green are not good examples, but let's take blue for a good example. You see how there's cyan blue, there's normal blue, and then there's dark blue, and then there's purplish blue. There's lots of blues that we could pick from, and out of a scale from 0 to 9, for all the other digits, the ones actually controls which blue we're going to be using, or which color we're going to be using. The higher it is, the higher the ones place are, the closer that color is to becoming the next color. So if it's set to 9, if the ones place was set to 9, then the blue would almost become a purple. But if it was set to 0, then it would be just right after green and be a very light cyan blue. And that's it. So let's take an example. And we're going to decode or color code the Forpy for 2569. Well, first, the thousands digit is used as color. The second color of the rainbow is orange, so that means we know that we have to start out with orange. We just want to make sure that orange is right after the red. Then we have the fives, which is the vertical. So we want to go a little bit halfway vertical, a bit higher here, because it doesn't go up to 10, it only goes up to 9. Then we want to go to 6, which is also like this, and then we want to go a bit further because it's one more. So something like this would work. And then finally we have 9, and 9 means the orange is about to become a yellow, so it's very close to being yellow. And this might be opinion based, but whatever, you consider to be still orange but as close as possible to almost being yellow. I would say maybe like this gold works. So to say this orange is very close to being yellow, but we can't call it a yellow yet. And then the yellow, therefore, now we've done horizontal and the ones place. We've done the absolute value of the color. And now we could find, and now how I like the marker answers, we could do 25, 69, and our color is kind of like a darkish gold, mainly because we started out with orange. We had a medium vertical, which means it's semi-bright, semi-dark. We also made it semi-saturated, so it's not fully orange, and we also made it almost look like yellow. So the thousands controls the color we're using. The hundreds controls how bright we want our color. The tens controls how horizontal we want the color, and the ones controls the absolute value of the color, how close we want that color to becoming the next color in the rainbow. So let's try another example. We got this next example. We got 4972. Let's start with 4. We already know the fourth color of the rainbow is green, so we want to use green that's almost yellow but not quite. It was just past yellow. Now we want to use 9. Since 9 is the max number, it goes all the way up as bright as it can. Even though 10, some people would say 10, but there is no 10 because the 10 is actually represented by 0, but the 0 means nothing. So if it was 0, it's black. But since it's 9, it's fully bright. Then we have 7. 7 would then we go horizontal for the 7, and we almost get a saturated color. Like 70% of the color is saturated. Then we get 2. So we just have to slightly move this a bit. And because this graph is pretty small. Therefore, our answer is 4972. And now you could use place values recognition to do Forpy. But why does this help? Well, let's give you advice. Maybe there's a complex color and it's kind of hard to give it a name, and it's kind of hard to give every color a name, a specific name, and some people have different opinions on what names mean. So by agreeing that we have a color, we could have a color spectrum each factor, which is an ingredient of what forms the color. Each factor has a scale of 1 to 10 to represent how much of that factor will be put into making that color. The max is 7,999 because 7 is the last color of the rainbow, pink, and 999 is as far as we can go. Therefore, there is no 8 or 9,000. But do you want advice to make a colorful color? Well, it's clearly subjective. But if you want a bright color instead of sloppy mess, kind of like this, like if you just do it randomly, a lot of the time you get sloppy mess like this color mess. this color mess, this isn't really a shiny gold color. This one's okay, but it's a bit greasy feeling. I know this is subjective, but if you want a nice, colorful, bright color, then this is what we would recommend. So first off, the thousands can be any color, but most people will agree on blue because most people's favorite color is blue, so we could put 5 as the blue color. Now, you could do a little bit of adjusting to see what works best for you. You could just go 9s. But you can let's get the blue. And you could just go 9s. So kind of like that, you get the real color. And then since the blue is kind of like a teal, because we need to go a bit further, so maybe it would be like around 3 to get a cyan. So we did 9 for vertical to be as bright as possible, 9 to be most saturated as possible, and we want 30% of the blue, aka 70% of the blue we have left until we reach the next color, which is purple. So for what we're gonna write. So in my opinion, bright colors would probably be something like around blank 99, and then you might do a little adjusting for the ones. Depending on some colors deserve low ones because they don't need to be they don't need to look like a different color, but some, like blue, do. And a 3 would work. I think a 3 would work nice. So it's very opinionable, but think about it, and you can create beautiful colors like 5,993. You could also use a simpler method, which only is 2 digits, but gets less accurate details. The 2-digit method has the 10s and 1s. The 10s is the color, the 1s is the brightness. So think of it like this. If we had 37, we would look at yellow. We wouldn't have to do any absolute value adjusting. We would just go to yellow, and we would look at the brightness of 7. And this is how it would work. The higher the number, the brighter it goes. It would go like this. It would go like this. As a time lapse. 0 to 9, like that. 0 to 9. So 7 would probably be something like kind of bright, like starting to get bright. So maybe so that's how you would do it in a simpler form. But it's ideal to use the 2-digit form. I meant the 4-digit form, where you have 4 factors that clearly determine your color. So now for practice, I want you to try these 2 examples, and I want you to practice. So, try these 2. For the next one, we'll just do 4, 8, 7, 3. So, keep in mind that the 2 middle numbers, 5 and 3, 8 and 7, are the most important to seeing your color because they both determine brightness and saturation of your color, meaning the 2 middle numbers determine what your color looks like. The other 2 numbers fills in the other holes of the facts of what your color should look like. So that's how you use the Forpy color language method, and I hope you liked it.